The topic for this assignment 2 presentation is called Adaptive Cruise Control. We are from Group 8 and here are our members in this assignment. This is an overview of the topic. Firstly, I will provide an introduction about the Adaptive Cruise Control, or in short known as the ACC, and I will explain about the function, operation, and the component in this system, following by the flowchart of design ACC control system, and I will provide a block diagram of ACC and explain about the detail of component function in a closed control loop system, ACC system challenges, and lastly will be conclusion. The adaptive cruise control is function to appear on production car that could truly be considered as a first step toward the autonomous driving. So it is a system designed to help the road vehicle to maintain a safe following distance and stay within the speed limit. Besides that, it also helps to adjust the speed automatically according to the road situation so that the driver don't have to do it by their own, such as when they want to decelerating, they will step on the brake pedal, while they want to accelerate, they will throttle it up. So at the following slide, we'll provide a systematic control system in a block diagram to show a clear image of the system during the operation and the component as well. So the advantage of the adaptive cruise control is to lower the chances of collision through the speed control. As you can see the animation of this short video here, this is how the virtual way to show that the adaptive cruise control detect in front of the car in a radar wave to detect the object in front of the car. So the next is about the function and operation of adaptive cruise control. It is to assist to maintain a steady speed that set by the driver. Once the system is activated, it will automatically adjust the speed of the car to match the speed of the car that in front of it. And beside that, it also can set the desire of the following distance, such as you want to set a distance that 1 meter distance away from the front vehicle. So the next is the component that install in the system that are employed the onboard computer and sophisticated sensors such as the radar system, actuator, and the speed or the distance sensor. These are all the significant components in adaptive cruise control. In this slide, we'll be explaining about the function of each component. The radar system sends the radar wave that reflect off object in front of a vehicle to predict and detect the path in front of it. So the actuator can be in the steering, braking, or acceleration actuator. For the steering actuator, it helps to maintain the car on its own lane so that it won't go off its own lane. And besides that, it also can guide it into a parking space, the parking lot, to modify the steering angle in response to a sensor information. For the braking actuator, it will apply a proper brake force to prevent or lessen the impact when receive the data about a possible collision. For the acceleration actuator, it helps to maintain the safe distance from other cars or obstruction, to modify the speed following traffic flow by regulating the throttle response. Last but not least, the distance sensor is to monitor the gaps of the car ahead, while the speed sensor is function as automatically accelerate or decelerate.
Okay, here is the flowchart description for how adaptive cruise control works. Okay, start. When the vehicle is started, it will initialize the system. Okay, driver have to engage the adaptive cruise control system. After the SCC control system is activated, driver have to set the desired speed for the vehicle. So the SCC control system will monitor the road condition and traffic using the sensor and cameras. It will also adjust the vehicle speed based on the road condition, such like curve or the traffic sign. And the SCC system will detect the lead vehicles by using the radar LiDAR sensor to detect a lead vehicle in the same lane. After that, ACC will measure the distance to the lead vehicles and the relative speed between the two vehicles. It will also compare the measured distance with the safe following distance. So based on the current speed and program safe distance parameter. After that, it will adjust the vehicle speed also. So when the distance is less than the safe following distance, it will slow down the vehicle. Or if the distance is greater than the safe following distance, so it will safe to do so, accelerate the vehicle to the set desired speed. Okay, after that, so it will the SAC will also maintain the safe distance after after adjust the speed to maintain a safe distance from the vehicle from the lead vehicles. So if the driver wanted to override the SAC system, the SAC also allow the driver to manually override the SAC system by braking or accelerating. If the driver wanted to disengage the active cruise control system, so the vehicle have to come to a stop, and then the SAC system will stop functioning.
We will now talk about the block diagram of the ACC system. Firstly, we have the user input, where the user turn on the ACC system and set a desired speed. It will then be followed up by a radar sensor, which sends a signal to help scan the surroundings, provide information on opposing vehicle speed, as well as the distance. We then have two controllers, which are the speed controller and actuator controller. Speed controller will send out instructions to the actuator controller, while the actuator controller carries out the instructions but also link it to the throttling and braking system of the vehicle, which will then result into a vehicle speed feedback that links back to the controller. Moving on to the next slide, which is the function of each block diagram in the ACC system. As previously mentioned, the user input is where the user engages or disables the ACC system, set a speed that is desired by them. The radar sensor is then employed to sense the object that interferes the vehicle's path. Scanning surrounding provides information on approximate speed, distance of the opposing vehicles. This will also help to determine the required distance and speed compared to opposing vehicles, ensuring it is within safety distance. Speed controller instruct the actuator controller to alter the speed when it's necessary, while the actuator controller carries out the instruction but also link it with the throttling system and also the braking system. The throttling system will either increase, decrease, or maintain the speed of the vehicle based on the user's settings, while the braking system will slow down the vehicle when it's necessary. The vehicle's chassis will also have an impact on the vehicle's speed and acceleration, as car physical characteristics such as aerodynamics will be impactful. Lastly, vehicle speed feedback will track the vehicle speed and feeds back the information while also precisely maintain a safety distance and speed.
Alright, for the next part, I'll be explaining about the controller system, how it works using the block diagram. So, the initial stage, the user will set a specific speed. In this case, we are using 60 km per hour. Therefore, the ACC has to run based on that speed. It cannot be changing, or it cannot be increasing or decreasing. So once the speed is set, the information goes to through the next part, which is the sensor. So in this case, we are using the radar sensor. Based on the block diagram, you can see we use the radar sensor. Radar sensor is a type of sensor that detects a stationary or a moving object. So once the radar sensor detects or any object, the information or the data will be transferred to the next part to scan any obstacles in front of that vehicle. So by doing that, the system knows and it can estimate a specific speed and distance. So this process is called the sensor process. So the next part of block diagram will be the speed and actuator controller. The speed controller itself alter to make sure that desired distance and speed is well calculated. So for example, we used a 60 km per hour as speed, so it should be calculated well. And the actuator controller is a response mechanism from the speed controller. It basically receives the data and performs it. And the next part of block diagram would be the controller process. So under the controller process there are two parts. One is throttling and the next one is braking. So throttling and braking are there in order to control the speed and power of the car. So this will be helpful when there's a obstacle in front of the car. And lastly, the last part of the block diagram would be the feedback. So when there's no obstacle in the surrounding, the vehicle speed is fed back into the system. So now the car will travel at a specific speed or specific distance until a new obstacle appears. So when, let's just say, if a new obstacle exists, the system will recalculate to find the new speed and the new distance. So that will be the new desired speed and distance.
Adaptive cruise control (ACC) system, while beneficial for improving safety and reducing driver fatigue, face several challenges that can impact performance and reliability. One significant issue is sensor limitation and failures. ACC system relies on sensors such as radar, lidar, and cameras to detect and monitor other vehicles, but these sensors can be compromised by environment conditions like rain, fog, snow, and dirt, leading to reduced accuracy or complete failure. To address this, implementing sensor fusion technique, where data from multiple sensors is combined, can enhance reliability. Additionally, regular sensor calibration and maintenance along with the use of redundant sensors can help mitigate this issue. Advanced cruise control systems face challenges in complex traffic scenarios and sudden maneuver by other vehicles. In heavy traffic or at intersections and merging lanes, ACC system may struggle to accurately predict and respond to the action of other vehicles. Advanced algorithm using learning and AI can enhance the system ability to navigate this complex scenario while integrating vehicle to everything V2X communication can provide additional information about the traffic environment. Additionally, driver may become over-reliant on ACC system, leading to reduced attention and slower reaction time if manual intervention is required. Implementing driver monitor system to ensure the driver remain attentive along while providing clear alerts and requiring regular driver interaction with the system can help maintain driver engagement and mitigate this risk. To address driver over-reliance issue, implementing driver monitoring systems that ensure the driver remains attentive, along with providing clear alerts and requiring regular driver interaction with the system, can help maintain driver engagement. Additionally, software or hardware malfunctions can cause the ACC system to fail, potentially leading to accidents. Rigorous testing and validation during the development phase can help identify and resolve potential issues. Incorporating fail-safe mechanisms that alert the driver and safely disengage the ACC system in case of a malfunction is also crucial for ensuring safety.
So for the conclusion part, the ACC control system can achieve the driving safety and bring the driver a lot of the convenience. But the challenge includes the sensor limitation, predictive algorithm, driver engagement, and robust regulatory framework. Continued research and industry collaboration are crucial. For the second point, it made up of several components such as the radar system and sensors and so on. The last point for the conclusion, the control system of SCC is indicated by a block diagram to provide a clear concept of operational. So this is the all the conclusion point.
So these are the references that referring to a website. This is the end of the presentation. Thank you for watching it.